Hi folks, welcome back to Math with Captain Rod. Making this video here to help you understand how to find horizontal asymptotes. So the first thing is recognizing when you'll have them. All right, and you have to look at the numerator and the denominator of these rational functions here. And anytime the numerator has a higher order than the denominator, that means anytime the denominator is a higher order than the numerator, that means the bottom of the fraction gets big, much bigger, faster than the numerator does. And what that does is it drives the function to 0. So anytime that occurs, y equals 0 will be a horizontal asymptote. The other possible horizontal asymptotes you get is when they have the same powers, the numerator and denominator, or they are of the same order. And then what will happen is y equals some constant or some number will be your horizontal asymptote. So I'm going to go through some cases here and chat about whether they have them and what the horizontal asymptotes are, starting with this first one here. So at the top of that, you notice you don't even see an x at all. You could think of it as like 2x to the 0. So one could argue the top is 0 order and the bottom is second order. So there's an example where the bottom is higher order than the top. So when x gets big, we say like goes to infinity, f of x is going to 0. So y equals 0 is our horizontal asymptote for that top example. All right, next example. This one. So the top is second order, the bottom is second order. So here's an example where they have the same order, so these are going to go to some constant. Now, there's a kind of a math way to do this, and then there's what I would just call it the gut instinct method, I guess, if you will. And I'm just going to do this the super simple way here and kind of avoid the little bit of math that goes with this. All right, when x is large, so like when x, we'll say, goes to infinity here, then this function is approximately equal to x squared up top and just x squared in the bottom. Because when x gets really large, these two terms here and here don't matter compared to this. I mean, try it. Take like 1,000 and square it, and then compare that to 1,000 squared plus 1,000. They differ by a very small percent. So basically, you can just kind of lop these off and say that when x is large, the function is approximately equal to this. It's not exactly equal to, but it's approximately equal to. And you'll notice these cancel, and we get 1. So y equals 1 is our horizontal asymptote there. Right? We're going to do the same thing here. If x goes to infinity, this function is approximately equal to 2x squared up top and just x squared in the bottom. And these cancel, and we get 2 out of this. So y equals 2 is our horizontal asymptote for that third function. So just meant to be kind of an introductory video here, or a quick and dirty video about how to look at a rational function and pick off the horizontal asymptotes. I hope this has helped you with that. Have a great day.